Okay, we go to the paper. Okay, guys, so we're supposed to discuss, of course, the AS trial papers. So I told you to do from the bottom, right? From the bottom, August 19. Okay, so August 19 and paper 2 and August 19, paper 1. Paper 2, any questions before I open? Let me open this paper. So today we just troubleshoot whatever problem you have. So this paper, any problem you face? Anyone?
So 4A.
4A. Okay, so let's see, go for 4A. This question. 4A. Okay, everyone, just maybe you might have problem if you never tried. Okay, okay, the others, please have a look. An electric wheelchair powered by a battery allows the user to move around independently. One type of electric wheelchair has a mass of 15 kilogram. Mass of 15 kilograms. Has a mass of 15 kilogram. The maximum distance travel on the level ground is 12 kilometer. Carrying a user of 65 kilogram. Or the wheelchair is 55 kilogram. The maximum distance you can travel level ground is 12 kilometer. 65 kilogram traveling, carrying a user of mass kilogram and traveling at its maximum speed of 1.5. Okay. The battery is 12 volt, this much of column. Show that the average power output of the battery during the journey is about 100 watts. Average power during the power journey is about 100 watts. So what is power? Power is energy per unit time, energy dissipation per unit time. Or we can go for work over time. But this case, I go for energy per unit time. Energy dissipated by the battery per unit time. How much of energy the battery released for a certain duration. Okay. So the battery used as an EMF of 12 volt, and it can deliver this much of charge as it discharges fully. Show that the power of the battery during this journey is. So yeah, E should be QV. Q times V can give you the energy it has. Okay, but we need to get the time. We don't know the time. How long this energy has been dissipated? Okay, so we don't know the time. So how do you find the time? So time, it traveled 12 kilometer with a maximum speed of 1.5 meter per second. Distance travel on the level ground is 12 kilometer when carrying and traveling at a maximum speed of 1.5. So I think these two factors can give you the time. Okay, give you the time. What is the time? So speed equals to distance over time. So we can find the time, distance over the speed. Distance 12,000 meter. And what is the speed? 1.5. I think there's a time here you have to put this. I think you get the answer. Okay. Let me check the mark scheme. See mark scheme. For A, right? Calculate the energy. Yeah, so that's working. The total energy is QV. Get that energy. And the time to dissipate this energy by the battery is 12,000 meter divided by 1.5. Like, you get the time for this energy used up. So the energy divided by that time, you get the power. It's about 110, so 108. It's about 100. Okay, you get the answer. Okay. You got an idea?
Yes, thank you, sir.
Any other questions? We don't have questions, we go to paper 1.
Sir, I don't understand 3C.
3C, yeah?
And so does that mean that the value must be near 100 volt, 100 watts?
Yeah, not exceeding under 10.
Okay.
Yeah, next is 3C, is it? 3C, yeah? Okay. So 3C, it's moment. Got steel cable, got B and C. Like cables AB and AC. AB and AC, which are attached to a single steel cable from a crane. Okay. Okay. So what do you want? Part C. Explain why the center of gravity of the beam must be vertically below A. Oh yeah, why the center of gravity must be below vertically A? Okay, why the center of gravity must be here? Okay, you see, what are the force acting on this bar? You have tension acting here. You have another tension acting here, and you have weight acting. Okay, this rod is in equilibrium. Yeah,
You can't see.
you can't see the question paper.
No, suddenly it not.
Oh, suddenly not, eh? Oh, can you hear me?
Yes?
Can, eh? So can you see the image now?
No?
You can't see. Okay, let me see. Why, eh? Back to the sharing one. Can you see now?
No.
No. Oh my god. What you are seeing now? Just my name.
Yeah, just your name.
Just
AS.
yes only. Oh, I don't know what is. Is it open share tray? Okay. I don't know. I just share the screen. Nobody can see it, eh?
No.
Okay, class. Class, let me come out from the meeting and join back, eh? Let me try. Okay, class. Let me. Okay, class. Can now. Can you see the paper now?
Yes.
Yes.
You can, eh? Okay. Something's wrong. I don't know what is the connection. Okay. So we go for 3C. So if anything not appearing, you better inform me earlier. Okay. So this rod, your friend asking for C. So asking why the center of gravity must be below A. That's a question of C. Explain why the center of gravity of the T must be vertically below A. Because the rod is in equilibrium. The rod is in equilibrium. Is in equilibrium. Okay. So therefore, it has two conditions. What is the two condition? The net force must be 0. Another one is what? The resultant moment, right? The resultant moment about any point. Any point must be 0. Okay, I don't know whether you remember or not in the PowerPoint last time I had discussed. If it's a rod is in equilibrium, the forces, all the forces must meet up in one single point. They must meet up in one single point. Okay, then only they say to be like moment-wise they are in equilibrium. Okay, so the T and this T, the T1 and T2, they are intersecting at a point A. So the weight, the line of action of the weight also must intersecting at a point A. All the force must intercept at the same point. Then only the moment say to be in equilibrium. So in this case, the center of gravity must be below A, so that all the forces are intercept at the same point. Therefore, the moment is become 0. That should be the answer. So which one? So this is for 3C, right? So there is no resultant moment. So moment do not balance, does not rotate, oscillate, and swing because A is the pivot. Yeah. So keyword is to have a resultant moment, all the forces must act on the same, pass through the same point. So therefore, mg must be below the A. Okay. Or another word, you can say, this is the idea. Okay. So to have zero resultant moment, all the force must pass through the point A, and therefore the mg must be, the center of gravity must be below the A. Okay.
Teacher.
Yeah.
Can I say that point A is the concurrent point?
Concurrent point. You must say there's a. What do you mean by concurrent point?
Like all the force intersect at that point.
Oh yeah, Ken.
Okay.
Okay. So the keyword here is for an object to be in equilibrium, the net moment must be 0. For the net moment to be 0, all the forces must be intersect. The line of action of all the forces must intersect at the same point. So therefore, center of gravity must be below the A. Okay. So, any other question? Hope you understand.
Yes,
Any other
thank you.
question? Yeah. Any other question? So if we don't have questions, then we go for paper 1. Okay. So no questions? Because paper 2, normally the mark scheme should be quite helpful. So we go to paper 1. Okay. So we go to paper 1. Okay, paper 1. Guys, can see the question paper?
Yes.
Can?
Yes.
Yeah, can. Okay, so this is the paper 1. Any questions? Hope someone tried.
Number 5.
5. Okay, we go to number 5. Okay, number 5. Okay, the others who I haven't tried, give a try. So this is a measurement technique. So Jean measures the mass and the speed of the trolley. The percentage uncertainty in the measurement of mass is 3%, and the measurement of the speed is 8%. A calculated value of kinetic energy, or this is kinetic energy of the trolley, will have an uncertainty of what? So many uncertainty questions. First, you get your formula first. So what's the formula? Energy equals to half mv squared. Then write the uncertainty formula. So changes of E over E should equals to changes of M over M plus 2 changes of V over V. Okay. So they're asking what? Okay, they're asking percentage of kinetic energy. So if they're asking for percentage, okay, if they're asking for percentage, I imagine like all multiply by 100%. This multiply 100%. This multiply 100%. So this is your question. The percentage uncertainty for kinetic energy. This is your percentage uncertainty of kinetic energy. So it's equals to what? Equals to percentage of mass and percentage of the velocity times 2. So percentage of mass is how much? 3. So 3% plus 2 times of the velocity speed. Say 8%. Yeah. So you get how much? So 3 plus 16. So you get 19%. So answer should be D. Answer given is D. Yeah.
Yes.
So this is how you do the working. Get the formula, write the uncertainty formula. If it's percentage, all times with 100%, then you get the answer. Okay. Can understand, Okay. Any other question?
Teacher number 8.
8, Okay. Okay, the others come on, give a try. Number 8, you also might have the same problem. A freely falling object on Earth has a speed of 5 meters per second. After falling 20 meters, its speed is, this is your kinematic, right? The 8, right? The freely falling object on Earth has a speed of 5 meters per second. After falling further 20 meters, speed is freely falling object on Earth. Okay, so U is 5 meters per second. A we know is 9.81. Then S is 20. We're looking for final speed, right? So V squared equals to U squared plus 2AS. You put your all information, then you get answer. 5 squared plus 2. So do you get the answer for that? 20 square root and KJV. What do you got? Anyone give a try? What do you got? 5 squared plus 2 times 9.81 times 20. It's your calculator. Give me the answer.
20. 20.
20, 20, right? Okay.
Yeah.
Good. So you got a B?
Yeah, the answer is given B.
So understand,
Yes, teacher.
Any other question?
Sir, 29.
Okay. 29, Okay, we go for 29. 29, stationary wave. Okay, the others look at the question. The stationary wave is set up stretch XY shown in the figure. At which point will have oscillation be exactly in phase with that at P. With that at P, yeah. You see, the first loop and the third loop, all the particles are in phase. See, when the string is appeared on top here the string also will be on top. So if this particle go down, here this particle also will go down. All the particle here will go down. All the particle here also will go down. So adjacent loops, they are always in phase. So who is in phase with P? Could be 1, could be 2, could be 4. 3 is out of phase P, because P is go down means 3, the second loop was placed downwards. So this particle is going up. The second loop always out of phase to the odd number of loops by how much? How many radian? By pi radian, right? By pi radian. It's always opposite. So answer should be D, 1, 2, and 4. Okay. So any question about 29? So odd numbers of loops, they are in phase. Okay. When this goes down, this also will go down. Okay, like a string, like a string. When this goes down means the odd number of loops will go down. So the particle always move in the same rhythm. So therefore they are said to be in phase. Okay. The second loop and the fourth loop, second and the fourth, they are in phase. They are in phase. But the first and second, they are pi radian of phase difference. Because they always travel in opposite. Okay. Okay, any other question? Can you understand 29? Can
Yes, thank you, sir.
Okay. Any other questions, guys?
Teacher 10.
Go to 10. Okay, 10. Joe is standing in an ascending lift. The magnitude of the force exerted on his feet by the floor must be ascending lift. The magnitude of force exerted on his feet by the floor must be equal to the magnitude of the weight. All this Newton's law. Newton's law is in the lift. Is standing there. Okay. So the force is. The force is up is the what? The normal force. Down is the weight. But this is ascending, ascending lift. So the lift is going up, but we don't know is it accelerated or not. And Joe is standing in an ascending lift. The magnitude of the force exerted on his feet, we don't know it's accelerated or not. If it is accelerate, then how to write the equation? The normal force minus the mg goes to ma, right? Force up minus force down is ma up. Okay, if it's accelerating. Okay, so if it's accelerating, then definitely normal force going to be greater than mg. Okay, if the acceleration is 0, then there is a possibility normal force is equals to mg. Okay, these are the prediction we can make. So what is the best answer covering this idea? Equal and magnitude of the weight. Yes, A is not wrong, A is correct, but not explaining everything. The A only happens when the acceleration is 0. So A is not wrong. We go for the best answer. equal to the magnitude of the force exerted by the lift floor by his feet. Equal to the magnitude of the force exerted on the lift floor by his feet. This is perfectly correct. B. Less than the magnitude of the weight also can happen. C also can happen if acceleration is negative. When you go up, but the lift is decelerating. A is negative. Then the normal force could also can be lower than mg. Okay, greater than it would be in a stationary lift. Greater than it would be in a stationary lift. Not necessarily one. Stationary lift is Fn is same as mg, but greater than it would be in a stationary lift. If the lift is starting move, Fn can go lower than mg, can go higher than mg. Depend is it accelerating or decelerating. So statement C is not really correct lah. Sometimes yes, accelerate yes. If A is positive, then D is correct. If it's decelerate, then D is not. Okay, but B is the best answer. Equal to the magnitude of the force exerted on the lift floor by his feet. Magnitude of the force exerted on the lift floor by his feet. See, this is normal reaction. Full name is what? Normal reaction. It's a reaction force. But what is the action? Action is force exerted by the person to the floor. Okay, that's the action. So the force exerted by the person to the floor action should be equal to the reaction. Okay, don't think the action is always mg. The action is the action we can't draw in the free body diagram of the person. Action we can draw when you refer to the lift. When you go for the lift body, we can say the force experienced down by the lift is the action by the person. Okay, so that's why normally force action won't appear in the equation or in the diagram. But be very sure the action is always equals to the reaction based on Newton's third law. Newton's third law. You see, you are standing on the lift, you experience a reaction of 20 Newton mean 200 Newton means 200 or let's say 500 Newton means you experience reaction means your action should be 500, right? Your action, because it's a reaction, the 500 Newton is a reaction. Reacting to what? Reacting to your action. What is your action? The feet exert force to the floor of the lift. That is action. So B is the best answer based on Newton's third law. Okay. Any part you don't understand?
Okay. Okay.
Can,
teacher.
Yeah, the A, B, A, C all correct, but never cover the entire information.
But the question said ascending, right? Shouldn't be the reaction greater than the weight.
If it's ascending, we don't know is it accelerate or not. If ascending with a constant speed, then reaction same as the weight. But if it's ascending with acceleration, then reaction going to be bigger than the weight one. If it's ascending with the deceleration, the normal force can be smaller than the weight one. So there is possibility.
Can we just
okay.
the best answer?
Yeah.
Let's find the
So
best.
yeah, B is the best answer. So every action there is an equal and opposite reaction. It covers everything. Okay, the force exerted by the feet to the floor is the same as the reaction force, which is actually from the floor to the feet. Okay. Okay, any other question? No other question.
Teacher, can you
question
explain
14.
18?
Number 18. 18. The others, what number? We go for the lowest number first.
14.
Oh, so we go for 14 first. We go for the lowest number. Okay, 14. So the others look at the question. A block of mass m slides down an inclined plane with a constant velocity as shown in the diagram. E naught was the total mechanical energy of the block. E naught is the total mechanical energy of the block, the start of the motion. Or E naught is the total mechanical energy of the block at the start of the motion. Okay. What is the total mechanical energy of the block after traveling a distance of d down the plane? Or moving at a constant speed. So lost. So, okay, this is tricky. Block M slides down, the constant velocity shown in the diagram. If E naught was the total mechanical energy, E naught means mechanical energy means the potential plus with kinetic. That's your mechanical energy. Mechanical means potential plus EK. So when it's at top, it has a certain EP and EK. When it slides down, there is a friction acting up. And it was constant velocity. So you remember the formula I told you, the work done by the thrust equals to gain EP. What else? Gain EK plus heat. Heat. This is the formula must come to your mind. Okay. Okay. Now, what do you want? Total mechanical energy about d distance. Okay. What is the total mechanical energy of the block after traveling? So they want what is the total mechanical energy after that? Okay. So total mechanical energy means the new EP plus EK. So mechanical energy is here. Good. So minus with the heat, minus with the heat. You minus with the heat. Okay. You see, if this surface is a frictionless surface, means EP plus EK when come down also, the EP plus EK going to be what? Going to be constant, right? Constant. If what? If no friction. If no friction, that means no friction means no heat. No heat, the total EP plus EK will be the same. The only thing is the EP going to convert to EK, but the total mechanical energy going to be constant. But because it goes down, and there is a friction. There is a friction acting down upwards. So heat generated. So the total energy, the EP plus EK minus with the heat, is the new. This is the new total energy. This is the new total energy. Okay. So E naught minus heat. E naught minus heat is your new energy. So E naught, what is your heat energy generated? Heat is work done by the friction. So F times D. F times D is your energy. So it should be B. So F times D. F times the D. The work is force times distance parallel to the force. So FD. Answer given, is it B?
Yes.
Do you get the idea?
Yes, thank you, sir.
Can, okay, good, thanks. Okay, next is what? 18. Let's look at 18. Okay, the others, liquid of density rho and mass m is thoroughly mixed with another liquid of density 2 rho and 3m. There is no change of total volume. What is the density of the liquid mixture? What is the density of the liquid mixture? Okay. One is density rho and m. So one body has mass of m, the density is rho. It was mixed with another substance, which is what? Density is 2 rho and 3m. After they mixed, you get a new mixture. Okay. So this mixture, they're asking what is the new density? What is the new density? Okay, how to find the new density is the new mass. The new mass, what is the new mass here? So m and 3m added become 4m. So the new mass is 4m. Okay, and the problem is the volume. How much is the volume here will be? Volume is the trap. We assume rho as m over v. We assume rho as m over v. So if this is rho as mass of m, so this volume we take it as v. Okay, this should be how many v? 2 rho. So 2 rho is equals to mass was 3m over this should be how many v? The x how many v? X equals to how much you get? 3m over 2 rho. So 3m over 2 rho is 3 over 2 v. You see here from the earlier formula, what is v? V is m over rho. M over rho is v. Here for 2 rho, 2 rho is 3m over the new volume x. Find the x. X is 3m over 2 rho. So m over rho is what? M over rho is v. So I put it as v. The conclusion is this as a volume of 3 over 2 v. Okay. So if this is v, this is 3 over 2 v. What is the total new volume now? The volume added what? Do they say it's not compressed? There is no change of the total volume. They are compressed. So v 3 over 2v become how much? Is 2.5v. Or become 5 over 2v. So this is the new volume. Put it inside here to get a new density. 4m over 5 over 2v. So how much is this? This is 8 over 5 m over v. So what is the new density? 8 over 5. Oh, m over v is what? M over v is density. So it's rho. So it's 8 over 5 rho. So answer is D. The trick here is the volume. You have to create a formula. You have to take it as density is m over v. M over v. When it's 3m 2 rho, you find the v in terms of v. It's 3 over 2v. When rho m, volume is v. So it's 5 over 2v. And 4m. Okay. Any questions here?
No, thank you, teacher.
Okay, good. So, any other questions? No questions?
Sir, for question 14 just now,
Yeah.
won't there be decrease in potential energy?
Yeah. Potential energy decreases. Kinetic energy will rise. Okay, kinetic energy will rise. But the mechanical energy means the EP plus EK was what do you call? Packed together as one single mechanical energy. That's why they put E0. E0 is actually EP, EK inside. When, yeah, you said, yeah, potential energy drop. Yeah, the final answer here, the final answer you're getting here is the drop in potential energy, drop in potential energy. The potential energy here, let's say originally 8 joule. Okay, let's say 8 joule. When come down here, the potential energy, let's say, is become 5 joule. Say 0 joule. Let's say the potential energy. The 8 becomes 0. All turn to become heat. Okay, if it's halfway here, let's say your potential energy is 3 joule. 8 joule become 3 joule. Okay, so what happened to the 5 joule? 5 joule become heat because of heat generated, FD. So yeah, there is potential energy is dropping. Potential energy is dropping. The changes in the potential energy is the heat energy. Because you see from this formula, no thrust, no gain in kinetic. Okay, so the gain in EP is the heat energy. Is the heat energy. Okay, so whatever potential drops here, the gain is actually 8 joule become, let's say, 3 joule. So it become, the gain is negative 5 joule. So the heat is become 5 joule. It's tend to become 5 joule. Okay.
Oh, I understand now.
Understand now.
Okay, thank you.
Any other question?
Number 30.
Any other question? Yeah.
Number 30.
13. 1 3 or 30. 30. Okay, guys, come on. 30. It's superposition. When two identical water waves travel x and y to meet a point P, the frequency waves is 0.4 hertz. The wave emitted are in phase. They are in phase. So if this start with crest means this also start with crest. They are in phase. In phase. Okay. So frequency is 0.4 hertz. Okay. Wave from X takes 3 seconds to arrive at P. So X took 3 seconds to arrive at P. So you know the time. Okay, you know the time. 3 seconds to arrive at P. Wave source takes 3.5 seconds, okay, to arrive at P. What is the phase difference in radiance between the two waves at P? Two identical water waves. Two identical means their speed same, their wavelength same. They also same frequency, identical one. So because they are identical, you want to find the phase difference. If they are identical, 0.4 hertz. Okay, oh yeah, I got the idea. If the frequency is 0.4 hertz means, okay, what is the period? Period is 1 over 0.4. So how much you get? 10 divided by 4 is 2.5. Okay, second. So this is period. Period. Okay. So first wave travels 3 seconds. Took 3 seconds to reach the point P. How many wavelength from X to P will be? Period is 2.5 seconds. 2.5 seconds means 2.5 seconds it take one wavelength. And extra how much? 0.5 seconds. 2.5 seconds is 1 lambda. 0.5 seconds will be how many lambda? 0.5 seconds will be yeah, sorry. We go for 3 seconds, 3 seconds. 3 seconds will be how many lambda? So 3 divided by 2.5 times lambda, how much you get?
1.2 lambda.
1.2 lambda. Okay, that means just a different color. That means this x1 and the amount of wave it travel is 1.2 lambda. Okay, the yp travel 3.5 seconds. How many lambda here will be? So 2.5 is 1 lambda. 3.5 will be how many lambda? Go for 3.5. 3.5 over 2.5 times 1 lambda. How much you get? 7 over 5 lambda, which is equal to how much? 7.5, 1.4, yeah, 1.4 lambda, correct? 1.4 lambda, 125, yeah, 4 lambda. So this wave travel like this, one wavelength, then a little extra lah. So this is 1.4 lambda. Okay, what is the path? Two wave. 1.4 lambda minus 1.2 lambda. The path difference is how much? 0.2 lambda. 0.2 lambda. So 0.2 lambda, what is the phase? The path difference is 0.2 lambda. 0.2 lambda, what is the phase for 0.2 lambda? Lambda, what is the phase? 2 pi radian. Okay. So 0.2 lambda, how many is the phase? So 0.2 times 2 pi radian. So this is how much? 0.4 pi radian. So this is the answer. 0.4 pi radian is actually 205 pi. So B is the answer. Okay, guys, you got the idea? You find the phase, you find the path difference here. The path difference, then you find the phase difference. 1 lambda of path difference is 2 pi radian. Okay, so how much the path difference here you get? 0.2 lambda. 0.2 lambda, how many radian? That's the answer. But to get this 1.2 lambda and 1.4 lambda, you have to use your frequency idea. Frequency. You find the period, then you put it how many wavelength pass by the P, from X to P and Y to P. Then you find the path. Yeah.
I can't see your screen.
Oh, everyone, is it?
Yeah.
What's the technical issue? Just now you can, when I scroll up, you can't see the screen.
Yeah.
Okay, let me try again. You see now?
Yes.
Can see now.
Yeah.
Yes.
So let me sketch again lah. So let me clear this. Okay, so let me explain this drawing. You see, they're asking what is the phase difference. They are asking what is the phase difference for the two wave meets at P. What do you do? You find how many wavelength at XP and how many wavelength at YP first. XP, check how many wavelength first. How many wavelength in XP? To check how many wavelength in XP, you find the period. Frequency 0.4, period is 2.5. So 2.5 is one wavelength. 2.5 seconds, one wavelength will transmitted in 2.5 seconds. Okay. So they said X to P took 3 seconds. 2.5 seconds, 1 wavelength. 3 seconds, how many wavelengths? That's why we did here. 2.5 is 1 lambda. 3 seconds is 3 over ratio lah. 3 over 2.5 times lambda is 1.2 lambda. So X to P found to be 1.2 lambda. Okay, because it travels 3 seconds. And 2.5 seconds is 1 lambda. So 3 seconds is ratio 1.2 lambda. For Y to P, it took 3.5 seconds. I say 3.5 seconds. So look, ratio again, 2.5 is 1 lambda. 3.5, how many lambda? So 3.5 over 2.5 times 1 lambda is found to be 1.4 lambda. So Y to P travel 1.4 lambda. So 1.2 lambda, 1.4 lambda. What is the path difference? Path difference is 1.4 minus 1.2 is 0.2 lambda, the path difference. Okay, so 0.2 lambda, what is the phase? So here the working, 1 lambda is 2 pi. So 0.2 lambda, how many pi? So you will get 0.4 pi. So answer you'll get B, 2 pi over 5. Answer is it B?
Yes.
So this is the working you should do. Find the path difference and then from the path difference, phase difference. Okay.
Teacher.
Yeah.
I have another class right now. Can I leave the meeting first?
Oh yeah. Sorry. You are having class now, eh?
Yeah.
Okay, class. So we continue tomorrow.
Yeah.
Okay. Bye.
Yes, sir.
Okay. Bye.